Hello, hello, mathematicians. It's Ms. Backfish, and I am here to do some synthetic division practice with you. So you may have already watched my video in which I kind of broke down synthetic division and walked you through it. One thing you'll notice here is all of the practice is with divisors that are just variable plus or minus a number. X plus 1, x minus 4, n minus 5, and x minus 1. Nothing like 2x plus 3 or anything like that. I touched on that at the end of my synthetic division video, and I actually left something out about that, so I apologize if you were confused by that. But I think most people don't even address synthetic division problems like that. They prefer to do synthetic division when we have our divisor variable plus number or variable minus number. So with me doing all this talking is a great time for you to have perhaps already paused and try these problems on your own. You can do that one at a time and then watch as we go through it. You can start a problem and only watch if you get stuck, or you could go ahead and try them all right now. That said, I'm going to jump in. Number 1. If I am dividing by x minus 4, excuse me, the root that goes with that particular divisor or that factor would be positive 4. So that's what gets put up here in the little box. And we have 2, negative 7, negative 8, and 16. And that's coming from the coefficients of this term. And then we're going to leave a blank row for another set of numbers and have a horizontal line. And finally, bring down the leading coefficient. That's the setup for synthetic division. We always set it up the same way. And once you have the setup, it kind of lends itself toward getting the ball rolling. We're going to do 4 times 2 and put our answer right here and then add. Remember that with long division we add. With synthetic, we subtract, With long division we subtract. With synthetic division we add. 4 times 1 is 4. Add. 4 times negative 4 is negative 16. Add. And I have no remainder. So that tells me that 4 is a root of this polynomial that was my dividend, and that x minus 4 is a factor of that polynomial. Now what's my answer? This is the remainder column. Sometimes we draw a little vertical line there. This is the constant, or x to the 0. This would be x to the first, this would be x to the second. If we had another one, it would be x to the third. So from right to left, we basically start x to the 0, x to the first, x to the second. So this is 2x squared plus x to the first minus 4. That is my answer. All right, moving on to number 2. If I can separate my paper. Number 2, we have 5x cubed plus x squared minus 7. Very important to note here, we're missing the x term. There's no just x to the first term. Just like in long division, that means we have to put a placeholder for it. So looking over here, the root that goes with that factor is negative 1. And then I'm going to start with 5 for my x cubed, 1 for my x squared, 0 x's, and negative 7 for my constant term. Leave room for another row of numbers, and then draw my horizontal line, and finally bring down my leading coefficients, kind of like priming the pump. Negative 1 times 5 gives me negative 5, and then add. Negative 1 times negative 4 gives me 4, and then add. Negative 1 times 4 gives me negative 4, and then add. This time I do have a remainder. Okay? This is still the x to the 0 term, x to the first, x to the second. So I have 5x squared minus 4x to the first plus 4. And very often the way we write that remainder is plus negative 11 over the divisor, the thing you were dividing by, which is x plus 1. And that's my answer. Number 3. Okay, this is division still. I just wanted to write it differently to remind you that fractions are division. It can be written in fraction form. All right, let's see if we're missing any terms. Do we need any placeholders? We do. We don't have an n squared term. We have n to the 4th, n cubed, 0 n squareds, 54n to the first, and 105n to the 0. So the root that goes with that factor is positive 5. And then I'm going to get those coefficients. Don't forget the missing one. 1n to the fourth, negative 8n cubes, 0n squareds, 54n to the first power, and 105n to the 0 power. Now I bring down my leading coefficient, and I start the process. 5 times 1 is 5, and I add. 5 times negative 3 is negative 15, and I add. 5 times negative 15 is negative 75, and I add. I didn't anticipate this one. Let's see. That's going to be negative 21. 5 times negative 21, voila, it's going to be negative 105, and we have no remainder, which is nice and handy. So that tells me that n minus 5 is a factor of this polynomial. It tells me that 5 is a root of that polynomial. And it tells me my division answer. This is the remainder. This is n to the 0. This is n to the first. Sometimes we like to just write it right there in line with where it is. N to the 0, I don't need to write anything. Anything to the 0 is 1. This is n to the first. This is n squared. And this is n cubed. Okay? Remember, it needs to make sense in terms of your final answer, the degree of the answer. That if I'm starting out with a dividend with a degree 4, and I'm dividing out of that 1n, then I'll end up with a degree 3. I had 4 n's, I take one of them out, I've got 3 n's left. Makes sense. Alright, so n cubed minus 3n squared minus 15n minus 21 is your answer. And I sincerely doubt you can hear this, but you might enjoy knowing because it is kind of cute, that my cat is asleep right next to my laptop and is snoring. So if you hear some weird sounds, and of course he stopped because I paused, but he was doing some really good snoring there. Last one. Not too late to pause and try it yourself if you feel more confident now than you did earlier. Here we go. 3, negative 2, 2, negative 1. 3 comes down. Add. 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 And this is my remainder. Did I do that right? I feel like I was not thinking clearly, but I guess I was. Okay, that's my remainder. This is the constant term, x to the first, x to the second. So 3x squared plus x plus 3 plus a remainder of 2 over x minus 1. That is my answer. I hope these practice problems have helped you feel more confident with synthetic division, and that you're going to just knock it out of the park on your test, quiz, homework, etc. Thanks for coming.